Every second of your life you are moving, not just through space, through time. Right now, at this very moment, you are hurtling into the future at the speed of exactly 1 second per second. But what if that speed could change? Scientists have told us for decades that time travel is impossible, a fantasy, the stuff of movies and comic books. Here's why they might be wrong. In 1905, a 26-year-old patent clerk in Bern, Switzerland sat down and changed everything we thought we knew about reality. His name was Albert Einstein. And what he proposed in his special theory of relativity was so radical, so counterintuitive, that even the greatest scientific minds of the era struggled to accept it. He said this: "Time is not a constant. Time is not a river flowing at the same speed for everyone. It is more like a fabric, flexible, stretchable, and deeply, fundamentally connected to gravity and velocity. Move faster through space, time slows down for you. Get closer to an enormous gravitational source, a planet, a star, a black hole, and time slows down around you. This is called time dilation. And here is the part that should stop you cold. This is not a theory anymore. This has been proven, measured, observed. It is happening right now. The GPS satellites orbiting Earth, the same ones guiding your phone's navigation, have to account for time dilation every single day. Because those satellites move so fast and sit farther from Earth's gravity, their clocks run slightly faster than clocks on the ground. If engineers didn't correct for this, your GPS would drift by over 10 kilometers per day. Time travel isn't science fiction, it's engineering. But GPS satellites are small scale. What happens when we push these effects to their extremes? Imagine, and this is real physics, not fantasy, imagine you board a spacecraft capable of traveling at 99% the speed of light. You accelerate out of our solar system past Alpha Centauri deeper into the Milky Way. From your perspective, the journey takes 5 years. You age 5 years. You read books, you sleep, you eat. But when you return to Earth, hundreds of years have passed. Everyone you knew is gone. You haven't just traveled through space, you have traveled through time. This is called the twin paradox, one of the most haunting thought experiments in all of physics. And while we haven't built the spacecraft yet, the mathematics are rock solid. Now, let's talk about black holes. At the edge of a black hole, in a region called the event horizon, gravity becomes so extreme that space-time itself is bent almost beyond comprehension. Time near a black hole doesn't just slow down, it crawls. Theoretically, if you could hover just outside the event horizon for what feels to you like 1 hour and somehow survive, thousands of years could pass on Earth. You would return to a world that had evolved entire civilizations while you were waiting. That is forward time travel, real, mathematically valid, physically possible, if we had the technology. But the question that has haunted physicists for a century is this: can you go backward? This is where things get strange. Einstein's equations, the very same equations that gave us GPS corrections and predicted black holes, also permit the existence of wormholes. A wormhole is, in theory, a tunnel connecting two separate points in space-time, not just two different places, two different times. Imagine folding a piece of paper and pushing a pencil through it. Instead of traveling the length of the paper, you punch directly through. In 1988, physicists Kip Thorne and Michael Morris published a paper, a serious, peer-reviewed scientific paper, describing how a traversable wormhole might actually work. The catch? You'd need something called exotic matter, a substance with negative energy density, something we have never observed, may not exist, and have no idea how to create. But here's what's interesting. In quantum physics, the science of the incredibly small, we have observed something called the Casimir effect. Two metal plates placed extremely close together in a vacuum experience a measurable negative energy between them. It is tiny, it is fragile, it is nowhere near enough to hold open a wormhole, but it exists. And 20 years ago, we didn't think gravitational waves existed either, until we detected them. 30 years ago, we thought we'd never photograph a black hole, until we did. Science has a funny habit of turning impossible into inevitable. Of course, backward time travel opens a door to the most dizzying paradoxes in all of human thought. The grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, you are never born. But if you are never born, you can never go back in time. But if you never go back in time, they do meet. So you are born, and you go back in time, and you see the problem. Some physicists, including Stephen Hawking, proposed what he called the chronology protection conjecture, the idea that the laws of physics themselves conspire to prevent backward time travel, that the universe has built-in safeguards against paradox. Others propose the many worlds interpretation, the idea that every choice, every event, every moment of time travel simply creates a new branch of reality, a parallel universe where the paradox never occurs. And some, the most radical thinkers, suggest that time itself is an illusion, that past, present, and future all exist simultaneously in a four-dimensional block universe, and what we call the present is just the point our consciousness happens to be moving through. If that's true, then time travel isn't about moving through time, it's about moving through space. So, is time travel impossible? Forward time travel? No, we understand it, we measure it, we engineer around it every single day. Backward time travel? Unknown. Possibly forbidden by the universe itself, possibly hidden behind physics we haven't discovered yet. But here is what I know. Every generation of humans has stood at the edge of the unknown and said, that cannot be done. Every generation has been wrong about something. We are not the last word on what is possible. We are just the latest chapter, and the story of time, your time, my time, the universe's time, is still being written. If this blew your mind even slightly, hit subscribe. Next week we go even deeper. What happens inside a black hole? The answer is stranger than anything sci-fi has ever imagined. I'll see you there.